So they have asked us to find this angle C, and we see an inscribed angle here. And we don't have any information except for 2x. So it seems like we don't know enough, but we really do, because we go back to the old videos and look at it. Let's see this inscribed angle. This angle right here, if I trace this out, and I trace this leg out, I am left with this arc right here, right? And this arc right here. And we know the inscribed angle is going to be half the arc, all right? And we know that this arc right here is 180 degrees. Well, we have a theorem that says if one side of an inscribed angle is the diameter of the circle, and look, it's also the diameter of the circle right here, right? It's this arc, but it's also this diameter. Then the triangle's a right triangle, and the angle opposite the diameter, that's this one, is a right angle. So I just had to realize that to know that I could set 2x equal to 90. And then we'll divide by 2, and we'll get x equals 45 degrees. So the value of x is 45 degrees. Let's use inscribed polygons again. Here we have a quadrilateral inside a circle. So this is actually an inscribed polygon. Do you see how the vertices are on the circle? All right, there's a theorem that states that a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So if I'm trying to figure out what z and y are, I know that they're going to be opposite angles supplementary. So I will say y plus 120 equals 180, and subtract 120 from both sides. And so I have 60 degrees here. So this one over here, this is 60 degrees. Okay. And then these two would be supplementary. So I can say z plus 80 would equal 180. Subtract 80 from both sides. And you can do this the common sense method, which would just be, say, 180 minus 120, and on this one, 180 minus 80. Or you can do it algebraically like this. So this one right here is 100 degrees.